Have you ever been handed over a toolbox with 50 tools when you actually needed just one? That's exactly what happens when you force a class to implement more than what it needs to. Welcome back to another video on object-oriented programming using C Sharp, and the topic for today is Interface Segregation Principle, the I in Solid. Here is where we fix bloated design by giving each class only the tools that it actually needs. Let's get started. Now let's understand what interface segregation principle really means. In simple terms, clients should not be forced to depend on interfaces they do not use. What this means is, when you design interfaces, don't bundle too many responsibilities into one giant interface. That's the key of it. Instead, break them down into smaller, more focused ones so that implementing classes only deal with methods they actually need. Now let's bring this to life with a visual analogy. Here we see four professionals: a plumber, a carpenter, an electrician, and a mechanic. Each one is holding a toolkit designed just for their job. Think of it like an interface. I plumber, I carpenter, I electrician, and I mechanic. Now notice what's missing. They are not overloaded with tools they don't need. This is exactly how we should be designing interfaces. Each class, or in its analogy, each person, should only carry the tools or methods they need to do their job. Now compare this to what we saw earlier: one person carrying a overloaded, bloated toolbox feeling frustrated. That's what happens when you violate interface segregation principle. With ISP applied, things are clean, lightweight, and purpose-driven, just like these toolkits. Now let's bring interface segregation principle into real world. Imagine you're building a smart home ecosystem and you have different smart devices: a smart bulb, thermostat, smart lock, and a smart speaker. All of these devices are shown to implement a single interface, iSmart device, which means one interface is expected to support all kind of functionality. Maybe turning on and off, adjusting temperature, locking and unlocking, or even voice commands. But here's the problem. A smart bulb doesn't need to adjust temperature. A thermostat doesn't need to process voice commands. A smart lock doesn't care about playing music. Yet, if they all implement iSmart device, they are forced to have methods they don't use. And that's exactly what is ISP violation. Remember the rule: clients should not be forced to depend on interfaces they do not use. Here, each device is being forced to implement methods irrelevant to its actual purpose, leading to bloated, fragile, and hard to maintain code. So how do we fix this? We split iSmart device into smaller and more focused interfaces like iSwitchable, iTemperature adjustable, iLockable, and iVoice controllable. That way, each device only implements what it truly needs, just like having the right tool for the job. And did you also notice that from iSmart device, we are shifting to interfaces that is functionality focused, like iSwitchable for on and off, iTemperature adjustable for adjusting the temperature, iLockable, and iVoice controllable. These are all functional interfaces. They focus on one single function. That way, it becomes more granular. So how do we fix this? We split iSmart device into smaller and more focused interfaces like iSwitchable, iTemperature adjustable, iLockable, and iVoice controllable. That way, each device only implements what it truly needs. We converted a bloated iSmart device interface into functionality driven, smaller interfaces, focusing just on what is required. Now let's look at this example in the form of code that violates interface segregation principle. We have an interface called iSmart device. This interface represents a generic smart device and tries to pack all possible smart features into one single contract. But the problem is, Not every smart device supports every one of these features. Now take a look at smart light bulb, which implements iSmart device. This smart bulb can only turn on and turn off. That's totally fine. But it's being forced to implement play music, set temperature, lock and unlock, though it doesn't need them. And what does it do? It throws not implemented exception, a huge red flag that the class is being forced to depend on methods that it doesn't use. This is exactly what interface segregation principle warns us against. No client should be forced to depend on methods that it does not use. In this case, Smart Light Bulb is the client and it is suffering from a fat interface. Why this is bad? It violates clean design. It confuses developers. Why does bulb have play music, set temperature, lock and unlock? It kind of doesn't make sense for a smart bulb to have these methods. It increases maintenance risk. Changes in the interface affects classes even if they are unrelated, even if they are not using it. And it breaks testability. Unnecessary methods make unit testing much harder. How to fix it? The right approach is to split this interface into smaller and more focused interfaces. Now that we have seen a violation of interface segregation principle, let's look at a refactored version of code that follows it properly. We have split our design into focused minimal interfaces, each representing a specific responsibility. I-controllable interface represents devices that can be powered on and off. I-temperature control used only by devices that can adjust temperature like a thermostat. I-lockable applies to devices with locking mechanism like a smart door lock. I-audio playable for devices that can play music like smart speakers. Each interface is focused. No device is forced to implement something irrelevant. Smart light bulb implements I-controllable with two methods in its contract, turn on and turn off, exactly what smart light bulb needs. And smart thermostat implements I-controllable and I-temperature control. A thermostat can turn on and turn off and also adjust temperature, so it implements only those interfaces, nothing more than what a smart thermostat needs. And smart door lock implements iLockable. This device doesn't need power or music control. It just locks and unlocks. So it makes sense for smart door lock to implement iLockable. And then smart speaker implements iControllable for turn on and turn off functionality. And it, in addition to turn on and turn off, it also needs audio playable capability. So it implements iAudio playable and implements play music. Why this is a good design? This code is a perfect example of how to apply interface segregation principle. Each class only depends on what it needs. None of the methods throw not implemented exception. Code is modular, testable, and scalable. We have to split big interface into smaller role-based ones and let classes pick only what they need and nothing more than that. This is how you respect interface segregation principle to create clean and future-proof code. Now let's look at the benefits of interface segregation principle. Clients aren't forced to depend on unused methods. Now, this is the heart of ISP. When we design bloated interfaces, we force classes to implement things they don't need, which leads to poor design. With ISP, interfaces are small and focused, so classes only implement what they actually need, making them lighter and more maintainable. Improved code readability and maintainability. Smaller interfaces naturally lead to simpler and clearer code. Developers don't have to scroll through a list of irrelevant methods wondering, do I need to override this? ISP ensures each interface has a single clear purpose, which keeps your code base clean and easy to maintain. Better decoupling. When a class is tightly bound to a large interface, it effectively couples all the unrelated responsibility within it. By applying ISP, you reduce coupling dramatically. It allows components to evolve independently without any side effects. Easier testing and mocking. When interfaces are smaller, unit testing becomes straightforward. You are not forced to mock unnecessary members or maintain massive stubs. You test only methods your class truly depends on, resulting in faster, cleaner, and more focused test methods. Minimized risk of breaking changes. Now, this one is huge. When interfaces are lean, making a change to one of them doesn't risk breaking dozens of unrelated classes. With ISP in place, changes becomes localized and the risk of ripple effect is significantly reduced. This means more stability and less stress during refactoring. The interface segregation principle helps us build focused, maintainable, and testable software by ensuring classes only depends on what they truly need. And it's a big win for any code base. Thank you for watching our video and do subscribe our channel for more such videos and thank you very much for your support.